Hello everyone. Today our second class of our third chapter electrochemistry. Today we'll discuss Daniell cell. Daniell cell is one of the types of galvanic or voltaic cell in which special type of electrode is used. One electrode is made up of zinc metal, another is of copper metal. Since it is zinc metal, the salt should be salt of zinc, that's why zinc sulfate. Here also copper sulfate. This one is salt breeze to maintain electrical neutrality. Now see, it is anode and it is cathode. Since it is anode, oxidations happens here. Due to this oxidation, electrons flows to that electrode in which reduction reaction is carrying out. Since electrons are flowing from here to here, that means in this direction, that's why current is flow in the opposite direction, this direction. Okay, now see what is the chemical reactions behind the anode and cathode. At anode that means left hand electrode. In some cases left hand electrode also called. In anode oxidation happens, that's why zinc solid goes to zinc 2 positive aqueous 2 electron. This one is oxidation because loses electron. At cathode reduction happens, right hand electrode. Okay, copper 2 positive takes electron and forms copper solid. Remember here this is zinc solid and here also copper solid. The oxidation state of this zinc and copper is 0. That means here is 0. Okay, now this one is oxidation reaction. Now here is the overall reaction. Simply just add the left hand side and add the right hand side. Here zinc solid, copper 2 positive aqueous, copper 2 aqueous, 2 electron is cancelled this. Okay, because in both the sides 2 electron is there, that's why it is cancelled. And here zinc 2 positive aqueous and copper solid. In other way, zinc 2 positive aqueous means the zinc sulfate here is 2 positive 2 negative. That's why I have written complete salt. You can write this way or this way. Both are correct. Zinc solid, copper sulfate aqueous goes to zinc sulfate, copper aqueous. Okay. Now, see, in specially Daniell cell, the maximum potential developed is 1.1 volt. Remember this one, 1.1 volt, where the concentrations of the two solution is 1 molar. The concentration should be in 1 molar, so that we get the potential is 1.1 volt. Remember this one is the particular case of Daniell cell. Now 3 cases is there. Suppose practically we are observed that E external is less than 1.1 volt. What is E external? E is the potential from external source. Suppose we are giving the potential less than 1.1 volt to the cell. Okay, now what happens when the external potential is less than 1.1 volt? Then electron flows from zinc to copper. Current flows from copper to zinc because it is in opposite way. Electron flows from zinc to copper, and electron from copper to zinc. Then zinc dissolves at anode and copper dissolves in cathode. Okay, this one I explained. This one, the external voltage here is less than 1.1 volt. Now when external voltage is equal to 1.1 volt, that means as exactly 1.1 volt. Okay, exactly 1.1 volt. Then no flow of electron is, if no flow of electron, then there is no current. Okay, that means no chemical reactions. Remember one thing, maybe I missed. Okay, no, here it is the maximum potential developed. Okay, then the Daniell cell can produce the maximum amount of potential difference is 1.1 volt. Okay, where the concentration of solution is 1 molar. Next, this one. Now when when the external voltage is greater than 1.1 volt, if external voltage is greater than 1.1 volt, then the chemical reaction reverse. That means electron flows from copper to zinc. Electron flows from copper to zinc, and obviously ion will flow from zinc to copper. Zinc to copper. Then copper dissolved at the zinc electrode, and copper dissolved in the copper electrode. Okay, then zinc dissolve. Okay, this one maybe, wait, let me see. Yes, it is correct. Yes, it is correct. Zinc deposited, not dissolved, first one. Zinc deposited at zinc electrode, that means anode, and copper dissolves in copper electrode, that means cathode. Okay, this one about the Daniell cell. Remember, this one is a very important topic. In many years, question comes from Daniell cell. Okay, our next topic is cell potential. Now, what is cell potential? Cell potential is simply the difference between the two electrodes. Okay, two electrodes potential of a galvanic cell. See, in a galvanic cell or voltaic cell, two electrodes is there. One is cathode and one is anode. Each one of these electrode have individual potential, and this difference between this individual potential is called the electrode potential, cell potential. Okay, now E cell, that means potential of cell is equal to E cathode minus E anode. That means potential of cathode minus potential of anode. Okay, now E cell equal to E right hand electrode, that means where cathode electrodes is there, right hand electrode. In some cases ER is there, and E anode means left hand electrode, which is EL. In some cases E left is written EL. Okay, now remember one thing, it is experimentally found that EL equal to always negative. That means potential of anode is always negative, and potential of cathode, that means right hand electrode, is always positive. Okay, remember this one. It will help in the numerical part. Okay, to identify which one is oxidation, which one is reduction, or which one is electrode reductive, which one is reducive. Now, next topic is the EMF. EMF means electromotive force. EMF, electromotive force. Now, what is electromotive force? The electromotive force is the potential difference between the two electrodes when no current drawn through the cell. When there is no current flowing in a cell, then the potential difference is called the electromotive force. Okay. Next is the standard hydrogen electrode, that means SHE, standard hydrogen electrode. It is used as a reference electrode to calculate the other unknown, the potential of another electrode. Now see, it is used as a reference electrode to measure the standard electrode potential of the other electrode by assigning standard electrode potential of SHE is 0. That means it is assumed that the standard hydrogen electrode has the potential of 0 volt. Okay, now how it is constructed, or what is the cell representations of this electrode? Okay, it is consist of platinum electrode, that means foil, this one, platinum electrode. It consists coated with finely divided platinum dipped in the acidic solutions of 1 molar. Remember this one, 1 molar acidic solution. S plus means acidic solution 1 molar. the concentration of the solution should be 1 molar and pure hydrogen gas at 1 bar pressure is bubbled through the solution. Here hydrogen gas is pushed to make bubble in 1 bar pressure. In 1 bar pressure, the pressure should be 1 bar. Then the electrode is known as standard hydrogen electrode, SHE. Now what are the cell representations? If we see the cell representations, we will get H plus aqua, that means the solution, H2 gas that we are pushing from here, see, H2 gas, and then platinum electrode, which is made up of solid platinum. Okay, no doubt it is powdered, but it is solid. Next, how we measure the potential difference with the help of simple hydrogen electrode? See here. If the concentration of oxidized and reduced form of species in the right hand side and left hand side is unity, that means, see, concentration of the oxidized and reduced form of the species, concentration of the species in the cell is unity, that means 1, then the cell potential is equal to the standard electrode potential and is designated as E naught of the given cell. You see, E equal to E naught R minus E naught L. This naught means standard, where the concentration is 1. That means standard electrode potential, this one for right hand electrode, that means for cathode, this one is for left hand electrode, that is for anode, and this is the whole cell potential, that means standard cell potential. Now since EL naught, that means the electrode potential of anode in standard conditions, for standard condition is assumed as hydrogen electrode, which is 0, as I discussed earlier, okay, which is 0, that means standard hydrogen electrode. Now what is the equation become? This equation becomes here, if you put here 0, then cell potential, that means standard cell potential, becomes the standard electrode potential of right hand electrode, that means of cathode. Okay, from this concept we can calculate the cell potential or electrode potential. Next, let us take a simple example. Let us take a simple example. How to measure the EMF of a cell? See, here is a cell representation is there, where this one is for what? Hydrogen electrode, that means standard hydrogen electrode, and this one for another copper electrode. See, platinum solid, H2 gas at 1 bar pressure, H plus solutions in 1 molar, and this one is the double slash, and then copper 2 positive aqueous and copper. See, the measured EMF of cell is 0.34 volt. Suppose it is given, or experimentally we observed 0.34 volt, and it also the value of standard electrode potential of half cell corresponding to reaction. See, since this part has the electrode potential of 0, no, since it is standard hydrogen electrode, then this electrode, that means copper electrode, has the potential of 0.34 volt. Okay, from where we get? From this formula. Okay, now see, this 0.34 volt comes or shows the value from the only this reaction, not the hydrogen electrode, because here potential is 0. The whole value of potential comes from this equation. Copper 2 positive aqueous, when takes electron, 2 electron goes to copper solid. Okay, next we will see another example here. Suppose left hand electrode, that means anode, see, zinc solid is there and produce zinc 2 positive aqueous It's 1 molar, not bracket this one, okay? This one 1 molar. 1 molar is a solution. 1 molar, 2 electron is loses, that's why it's oxidation. In right hand electrode, that means cathode reduction happens. Now, overall reaction is this one. And this one example of Daniell cell, remember. If you just match copper and zinc, this is Daniell cell. Now, what is the standard cell potential? As we know, standard cell potential equal to E naught R minus E naught L. R stands for what? R stands for right hand electrode, that means cathode. L stands for left hand electrode, that means anode. See, this one we observe that this one R equal to 0.34 volt minus, since it is anode, that's why here this minus comes, and its electrode potential values calculated from experimentally and is found that 0.76 volt. Now if we just add this to value, we will get 1.1 volt, which is the electrode potential or maximum cell potential of Daniell cell. Okay. Next is the electrochemical series. See, various electrode or half cell have been arranged in order to their decreasing value of standard reduction potential, and this arrangement is called the electrochemical series. Now, what you can say? We can say the electrochemical series are the simple arrangement of the electrode potential of the electrodes or half cells, okay, which is arranged in decreasing order from higher to lower, decreasing order. Now it has some points to note, okay. First point, a negative E naught means, that means electrode potential, if it is negative, that the redox couple is a stronger reducing agent. Remember, if it is negative, then stronger agent. In other sense, you can say more the negative value of E naught, stronger the reducing agent. Okay, stronger the reducing agent. Second one, if it is positive value, higher the positive value, the reduced couple is the weaker reducing agent. That means stronger oxidizing agent. You can say stronger oxidizing agent also. Okay. Now see, in your book maybe in page, let me see. Okay, see this one. In your book, it's clearly given in page number 69. Okay, one chart is there from here to, see, from here to here, up to lithium, from iron to lithium. If you just note that the electrode potential, that means reducing value, is 2.87, which is positive. Okay, but here simply decreasing the values. See, decreasing the values, one point will come where the standard hydrogen potential is there, where the value is 0, and then the reducing potentials are decreasing up to 3.05. That means this one is the strongest reducing agent, and upper one, topmost one, is the strongest oxidizing agent. Okay, now what is the agent? You already know from class 11. Oxidizing agent means it has the potential to oxidize other species, and itself it will reduce. Similarly, here also it has the stronger tendency to reduce other, and itself it will oxidize. Okay, next, Next, for anion, it is found that the tendency to behave reducing agent is increasing this way from thiocyanate 3 negative to chlorine negative. This means chloride ion, which can be explained with the help of negative charges. Okay, as the negative charges decreases, the reducing tendency or reducing power tendency increases. Okay, this concept have not definite or exact explanation. It is particularly found in experimentally. That's why I'm using this way. Okay, now see, from the electrochemical series, in most probably 2019 or not 2018 or 16 short question comes in every year. There is a probability to come short question with the help of electrochemical series. Now see what type of question it is. Suppose here example. Suppose in a question some values are there, reducing values are there, all are reducing potential values are there, and question comes arrange in the increasing order of the reducing power, or inversely arrange in the oxidizing power, or you can say questions which one is the strongest reducing agent or which one is the strongest oxidizing agent, this way. Now if we just arrange by increasing order of the reducing power, then what do you know, negative value means stronger reducing agent. See, this one is the largest negative value, that's why it is largest reducing agent. See here. Then this one 2.37 mercury. Then 0.74, which one is chromium. Then which one, mercury, Hg, sorry, this one magnesium, this one mercury. Then 3.71 Hg, and this one at least positive value here. That means this one is the, for this particular series, this one is the stronger, or you can say strongest reducing agent. Okay, but this one is the strongest oxidizing agent. Okay, because it has the large positive value but it has the large negative value. Okay, thank you.